Hello. This is the second part of my lecture summary on the work of Sir Francis Galton. This covers his research concerning individual differences and the inheritance of intelligence. I will comment on Galton's interests in statistical methods and the social philosophy of eugenics in the third video. In psychology, Galton's greatest impact was in establishing the psychology of individual differences and in raising questions about the role of inheritance in intellectual attainment, questions which generated a massive and lengthy research program as well as considerable controversy. Galton's work here was at least partly sparked by the publication of Charles Darwin's groundbreaking 1859 book on the origin of species. Darwin, a distant cousin of Galton, had been mostly interested in the natural processes by which change occurred in animal species through the selective advantage gained by individual members of the species from the possession of particular characteristics. For example, birds with beaks able to extract a particular kind of food from their specific environments. But Galton was more interested in the well-established practices of selective breeding amongst animals and the application of these principles to humans. His own extended family included many eminent people, and Galton had noted that at Cambridge many of the men winning honours also had fathers and brothers who were honours winners. So Galton's basic research question became whether or not eminence was an inherited and inheritable trait. Much of Galton's life work was devoted to examining this question, or perhaps we should say proving this assertion, because there never seems to have been much doubt in Galton's mind about its truth. To investigate this proposition systematically, he undertook a laborious study of top-scoring graduates in classics and mathematics at Cambridge over the past 41 years, publishing his results in 1865 under the title Hereditary Character and Talent. He found that top scorers came disproportionately from certain families. This was followed by an enormously influential book, Hereditary Genius, published in 1869. In this, he first established how common eminence was in the general population. Thus, he counted obituaries in the Times for 1868 and some earlier years, and found that those so recorded constituted about 250 per million of the population beyond middle age, that is, about 1 in 4,000 people. Similarly, eminent judges, politicians, scientists, and other men of renown comprised about 1 in a million of the general population. Yet, of this tiny elite group, many were related to other eminent men. For example, of 236 judges in his sample, about 1 in 9 was a brother, father, or son of another judge. Judges also had large numbers of eminent relatives in other professions. The incidence was hundreds of times greater than in the general population. In sum, of the eminent people Galton recorded, 31% had eminent fathers, 41% eminent brothers, and 48% eminent sons. Indeed, the more closely related a man was to a man of eminence, the more likely it was that he himself was eminent. Clearly, Galton concluded, just as with physical features, a man's natural abilities are derived from inheritance. He rejected the idea that such differences were the result of effort and not based on natural differences. Regardless of the criticisms and controversies that his work has attracted, Galton, an amateur savant working outside of any existing research tradition, had established the study of hereditary influences on intelligence as a valid subject of psychological research. I will note in passing that Galton supported his conclusions not only with statistical evidence, but with a pioneering piece of statistical analysis, a topic to which I will return in the next video. Contemporary critics noted an obvious objection to Galton's work: the possibility that individual differences were due not to inheritance, but to environmental factors. Galton may have been correct in identifying a close correlation between the eminence of the individual and the eminence of their near relatives, but this relationship could be the consequence of common factors of upbringing and culture, as well as biological inheritance. Indeed, it was possible to point to the work of the Swiss botanist Alphonse de Candolle, who argued in an influential 1873 book for the importance of cultural factors in the development of science, showing that generally great scientists came from countries with moderate climates, religious tolerance, democratic government, and healthy commercial interests. Responding to these objections, Galton sought to distinguish more clearly the influences of nature and nurture, terms which he himself coined and which have remained part of psychological discourse. Thus, nature was all that an individual brought with him into the world. Nurture was all the postnatal influences. Nature gave an infant its latent faculties of growth and mind, whilst nurture was the environment in which that growth took place, and by which natural tendencies might be strengthened or thwarted, or wholly new ones implanted. Galton devised several methods to differentiate the relative importance of nature and nurture, but himself continued to believe that nature was the more important. The argument continues to the present day, with supporters of inheritance giving primacy to nature, and opponents of this view giving it to nurture. Galton's own role in devising these measures is largely forgotten. One method which we have already noted was his use of genealogical studies of the inheritance of eminence, a method which continues to be used in relationship to other psychological traits. A second method was the self-questionnaire, famously illustrated by a lengthy and exhaustive survey which Galton sent to 200 members of the Royal Society. This asked such questions as, how far do your scientific tastes appear to have been innate? Were they largely determined by events after you reached manhood, and by what events? By these means, Galton hoped to establish the relative importance of nature and nurture. He also asked a host of questions about such matters as the respondent's racial, religious, social and political background, his traits of character, his hair color and hat size. Amazingly, perhaps, most subjects completed this questionnaire despite its length. It was the first such questionnaire in history. Today, such compliance might not occur. Galton found that most respondents believed that their taste for science was innate, but that education had helped or hindered them. So he acknowledged the importance of education in particular as an environmental factor. Inheritance by itself was not enough, but was an essential factor. He published the results in his 1874 work, English Men of Science. Today, the limitations of this work seem obvious. Many of the questions yielded subjective answers. There were no comparison groups of scientists and non-eminent scientists, and Galton had as yet no way to measure the relation of factors to determine whether they were accidental or significant. Even so, his use of the questionnaire and subsequent analysis were innovations which were much copied by later researchers and at times have been of great value. The third and most important methodology was the study of twins. Without a knowledge of genetics, the exact difference between identical and fraternal twins was not fully understood by Galton. But nevertheless, he pioneered an approach which has proved to be of tremendous value in studies of the relative importance of nature and nurture. In particular, he realized that comparing those twins who had been closely alike as children, but were then raised apart, and those who were originally unalike, but had been reared together, provided an insightful means of assessing the relative importance of inheritance and environmental influences. Differences between identical twins raised apart would be due to environment. Differences between non-identical twins raised together would be due to nature. Of course, Galton then only had very crude ways of testing his hypothesis, relying again on self-reports. To that end, he contacted various twins, getting replies from 94 pairs, 80 of which were of close singularity, and 35 pairs in the end provided him with enough data to be useful, publishing his findings in his 1883 compendium, Inquiries into Human Faculty and its Development. Galton's account is largely anecdotal, with stories of identical twins playing tricks on people, being confused by teachers and even a fiancée, but he concluded that, firstly, unless one member of a pair of similar, that is, identical twins, had been affected by accident or illness, they were likely to remain similar in mind and body into old age, and secondly, that dissimilar twins in childhood did not become more alike over the years, even if raised together. Findings that were confirmed by more sophisticated modern studies. Lacking caution, Galton ignored the imprecision of his study and asserted that this proved that nature prevails enormously over nurture, as long as the differences of nurture were not extreme. That is, if each twin was raised in the same country and by persons of similar social rank. Related to Galton's inquiries into intelligence was his development of a number of mental tests. Initially, his criterion of mental giftedness had been essentially public reputation and professional success, but he came to see this approach as inadequate and also impractical for the wider studies he wanted to undertake. The new tests he devised sought to identify persons that he thought to be of superior intelligence more quickly and more easily. He made trial tests of a number of possible measures at the 1884 International Health Exhibition in London, where visitors could pay threepence to be tested and measured in what Galton termed the anthropometric laboratory for 13 characteristics, such as reaction time, keenness of sight and hearing, color discrimination, the ability to judge length, strength of pull and squeeze, strength of blow, height, weight, arm span, and breathing power and capacity. Acuity of the senses and reaction times were deemed particularly useful. Evidence for this included his observation that people who were mentally retarded had poor sensory discrimination, and in what we would now see as an outrageous piece of Victorian gender bias, that work which required sensory acuity, such as piano tuning, wine tasting, and wool sorting, was always done by men, presumed by Galton to be more intelligent than women. In all, 9,337 people were tested, and after the health exhibition closed, Galton continued his tests at the Museum of Natural History in South Kensington, devising a number of new tests, including the ability to estimate extension of distance, perpendicularity, discrimination of weights, and of intensity of odor. These again were seen as somehow related to intelligence. Ironically, whilst Galton's ideas were later enthusiastically embraced in the United States, Galtonian-style tests were soon found to have no predictive value, and were abandoned, a story which we shall examine in the last 4 videos of this section.